Right. Advent of code. We are behind. We last did day 8. They have come out with day 9, 10, and 11 since then. Day 8 was like around 10 times harder than all the ones we'd done before. So I wouldn't be surprised if we just stay behind a little bit. Day 9, we'll see if it's difficult. But the plan for today is, I guess we'll just kind of see where it goes. If day 9 goes by really quick, we'll do like a double feature. And if it's slow, then that's fine, and we'll do day 10 tomorrow or something. We'll see. We will see. As far as I remember, the plot is we are an elf. We are trying to get into the underground bunker of the North Pole to get Christmas presents out in time. We did like a password thing to get through the secret entrance at the top. We went to a gift shop and fixed some database records in the gift shop computer. We fixed an escalator. We took the escalator down to the print shop. We moved some paper around so that we could use a forklift to bust through a wall. Busting through the wall, I think, took us to the cafeteria, where we fixed some food stuff. We were helping track rotten food. We fall down the trash chute after goofing around. We find some cephalopods or octopus in there. We do some octopus math while the parent octopus help us get out of the trash chute, which brings us to day 7, where we ended up in a teleporter room, so we kind of got stuck in some teleporter area, and we had to fix the teleporters to jump us out to the playground. In the playground, we were doing something like, what was it? We were fixed something to do with like 3D junction boxes. Oh, we were trying to put up the Christmas lights. Okay. So, we have put up Christmas lights in the playground, and now we are on day 9, and we will see what is next. Akros? For some reason I've always thought there was an extra R in there. Thank you for it's a streak. I don't know what a streak is. It shows up on my screen like you gave me money. But I guess that is different. Anyways, what's up? Day 9. We slide down the fire pole in the corner of the playground and land in the North Pole Base movie theater. Let's go. The movie theater has a big tile floor with an interesting pattern. Elves here are redecorating the theater by switching out some of the square tiles in the big grid they form. Some of the tiles are red. The elves would like to find the largest rectangle that uses red tiles for 2 of its opposite corners. Wait, okay, so there's a big grid. We have some red tiles, unknown other tiles, right? Other tiles are of undefined color. Elves would like to find the large rectangle that uses 2 of its opposite corners are red. So I assume that means that we're trying to like make a rectangle of tiles where there's a red one here and a red one here. I assume that's what they're saying. Something showing red tiles as this, other tiles as this, it would look like this. You can choose any 2 of the red tiles as opposite corners of your rectangle. Your goal is to find the largest rectangle possible. For example, you could make a rectangle as shown here, or I could make one here. I could even make a thin one. And I assume there's like overlapping is allowed. I see. So the tiles are already set, and we're trying to draw like a little box around them of the biggest area. Okay, so that's a little interesting, right? So you obviously have all of the X positions of one. How do I say this? So doing this in one dimension would be really straightforward, right? You take the minimum X and the maximum X. That's the biggest thing you can make. Now, in something like this, it's obvious-ish. Is it even obvious? I guess it's not, right? Like, looking at this, eyeballing it, I don't know if I think that this is bigger. There's this rectangle like this, and then there's also, like, this rectangle like this. And it's not, like, super obvious to me which one is bigger. There's something here where, like, do we have to test every rectangle? Is the question I'm trying to ask myself, right? Like, the obvious solution here is to just take every pair of guys and say, how big is the area of this? But I'm trying to think if there's some sort of, like, more intelligent thing to do. But I think we learned on day 8 that looking for the more intelligent solution before we actually get through the problem can really hurt us. Because we spent a lot of time thinking about like 3D spatial lookups, and then they weren't helpful. Was where we ended up at the end. Yeah, I think that's well. How big is our input? That's not that large. That's probably like a couple hundred lines. That's probably only a couple hundred lines. I guess you could also. Well, I was gonna say you could compare, like, you could keep track of like the largest x and y distances, and maybe leverage that in some way. But I don't think that's actually helpful. It really depends on like how fast a multiplication is, but I assume it's pretty fucking fast. So let's just do this. Let's just fucking run it. So we use our standard library to open a file. We go F is try current working directory open file of day 9 input text. And what are we doing? We're like trying to do there's some sort of parsing loop where we have, you know, x, y, x, y, x, y, and so we are doing some sort of I guess we need like a reader. So we will do this. We'll say f reader on reader buff. I think the naive solution will be sufficient. Sufficient's true, but like I was really thinking about, like, it's about fun, you know. The stupid solution is always good enough for these because they're not like computationally that difficult. But sometimes it's fun to think about the more fun solution, you know. Okay. So take delimiter exclusive. We're looking for new lines. And I guess there is the case where we hit the end of the file. Error end of stream. Otherwise, we're actually in error. And then we can look at the row itself. So we say index of scalar. We're looking for, I guess, probably in the row, the comma. And we crash if it's not there. We say x end, I guess. And we are saying that we have x is stood format parse int row from 0 to x end as probably a u32, probably. And then we have y as x end plus 1 onwards, easy peasy. And I guess we stick these somewhere. Yeah. Let's do points. We have a point here. X u32, y u32, and we have a bunch of these guys. I don't know. I think we saw like 300 of them would be a lot. Let's do points buff. Var points is an array list that wraps this buffer. And we can just kind of go here. We can say try points append with x is x and y is y. Okay. Then once we've got here, we can go like for points items. We probably want the index of this guy. And we're trying to compare every point with every other point. So we're kind of going like I plus 1 onwards, I guess. And I guess this isn't x and y. This is like a and b or something. I guess we need to go from 0 to points len minus 1 here because the last guy doesn't need to compare against anyone else. Yeah, so something like this. Something like this. And what are we doing? We're like looking for max pair is undefined, and I guess like max A, max B, I guess. And then, oh, do we even need the maximum? We just need the largest area. So it's like max area is 0, easy. And then we can do a little bit of max area is equal to max of max area, and what's the area here? It's like y dist is by minus ay, probably absolute value, which makes it easier if these guys are integers. Does it? I think so. Everything's easier if we work in signs here, because then we can go negative on the subtraction, and then we can absolute it at the end. Otherwise, you have to do like that like uint math bullshit, which is a pain in the ass. So let's do this. And max area is, I guess technically, I wonder if it's faster to do it like this, and then do the absolute here. I wonder. Okay. Std debug print max area. Max area. Boom. All right. And then let's start with the example input and figure it out from there. Day 9 input example. Okay. Zig run day 9. He's mad because our reader needs to be variable so that he can track his internal state. So true. Parse int requires us to write the base of the number we are parsing. And row is mad. Why? Whoa. Oh, because this is supposed to be the type first, then the row. My bad. My bad. This is mad because it's items len here. And we got 36. Is that what they got? No. Why? Is it inclusive? No. Okay, can we... Between 2.5 and 11.1. Okay, so let's look at this. So we have, let's print A and B. And the area, probably. Because we're probably doing something stupid here. So we're looking for 2.5 and 11.1. 11. Does that combo never happen somehow? Oh no, here. We got 36. But they're saying that it should be 50. So 11 minus 2 is 9. 5 minus 1 is 4. So that is, we are calculating the right thing. It must be inclusive. It must be. It must be inclusive. 2.5, 11.1 is 40. What the fuck? Am I misunderstanding the problem? Am I misunderstanding the problem? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 1, 2, 3, 4, 5. Oh, it's +2 maybe. Still no? What the fuck am I doing wrong? Am I stupid? Oh. Wait, hold on. You have to do it in the right direction. I'm a dumbass, dude. Okay, there we go. Max area of 50. 2, 5, 11, 1. Perfect. Perfecto. And then we just swap in our input. And we don't have our day 9 input yet, huh? It's a good point. That is a good point. Out of memory. Oh. More than 300? How many points are there? Oh, integer overflow? Okay. Interesting. I guess we kind of do a little bit of this. Throw some U64s at the problem. And we'll see if this is right. It probably is, because I don't know how we could have got that wrong. Easy peasy. Easy peasy. Okay, does part 2 get hard? Okay. So this is day 9, part 2. The elves just remember they can only switch out tiles that are red or green. So your rectangle can only include green or red tiles. In your list, every red tile is connected to the red tile before and after it by a straight line of green tiles. Ah, okay. The list wraps so that the first red tile is also connected to the last red tile. So, you have some sort of snake. In addition, all of the tiles inside this loop of red and green tiles are also green. The remaining tiles are never red nor green. The rectangle you choose must still have red tiles in opposite corners, but any other tiles it includes must now be red or green. This significantly limits your options. Right, because we can't do, like, this one with this one anymore. Okay, so it's good. Yeah, okay, part 2 in here is just, like, way fucking harder. Okay, can we think about this problem? I mean, let's just draw out, like, their thing, right? Their example is, like, a good enough thing here. So how do we determine which sets of corners are valid? So the obvious thing here is if you were to iterate all cells within your grid, right, you would obviously, in your box, you would find these. However, that sucks. Is there a way? Is there a way to do this better, right? So there's like raycasting is like a thing that's like immediately coming to mind, right? You can kind of like only iterate in one direction and look for an edge if you know that this is like a closed polygon. Right? Do we know that? I don't know if we know that. I want to render out our puzzle input. After we draw the lines, I think. Are all of the points always vertical or horizontal? If they're not always vertical or horizontal adjacent, then we're gonna have like a fucking problem, right? Because like, how do you render diagonal lines is unclear. But I think that we should assume that things are always horizontally or vertically connected. We know it says in the text that the last connects to the first, so we know it's closed. But I don't know if, like, you can do something like this, right? In which case, it's not closed. You know what I mean? Like, or maybe closed is the wrong word. But just because you have something that connects in a loop doesn't mean that, like, you have a reasonable shape. Do you know what I mean? It says they're always in the same line, same column. That would make sense. Straight line. The list wraps the first tiles also connect to this. Tiles that are adjacent in your list will always be either the same row as the column. True. Okay, cool. So I think that you could still end up in a case where you kind of go like this, right? And so this makes the problem different, if that makes sense. Versus if you have like something that is always kind of gonna be like one polygon like this. Now, does that actually change anything though? Like, you might be able to save having to check every point in the box by just like raycasting like this. You know what I mean? You know? Because I think that there's probably some constraint where if there is a rectangle where there is a hunk cut out, like I guess in this scenario you can't only check the edges, right? But I don't think that we can make this. You know what I mean? Like, I don't think this is possible given the problem definition. But I'm curious to let's render our input first, and then that will give us some clues about what we're supposed to be doing here. Let's do that. So first let's construct the lines. And we might be able to do all of this with vector math, actually. Right? Because you kind of know also, right, like what you actually have is this. Right? So, given this, there's probably some sort of bullshit you can do. Like, this is reminding me of some of the, like, font rendering stuff that we did. Where, like, the winding order, like, testing if you're inside or outside becomes, like, really easy with, like, raycasting outwards or something. And then I'm just trying to think. Yeah, it's something like if you raycast down from your corner, you only have to check the other vectors, not every point. Yeah, it's something like that. There's something like that. I haven't really figured it out yet. Let's draw the fucking input. Let's draw the input and then figure it out from there. So let's store these things as vectors, I think. And Two-Step was saying that I should store them as actual vectors, but I'm not sure if I want to do that yet. So let's not. Okay. So I guess we are doing something like this. Yeah, I guess this is 2 points. If you render it, you can just basically eyeball the solution. So true. So true. Okay. So I think we want to do this. Parse point. Point. Boom. And then let's take all the stuff in this while loop and throw it in here. Bop. And then we just return x is x and y is y. Guys, play nice. Okay, I don't know why this, because this is not interface anymore. There we go. Now that highlighting looks right, so then we can go parse point on reader interface And then while true, this is going to be parse point like this. And we have like the same failure conditions, I think. Then we have, I guess this is stupid, what I'm doing. I've just realized this is fucking stupid. We can store everything as points still. We don't need to store as vectors yet, because the vectors will be automatically kind of figure outable by the points buffer. So all we have to do is start rendering. So we have like ppm. Can we do create file test ppm? And in here we start writing out like writer buff, ppm buff. And we have writer is ppm writer with the buffer. And we go like for 0 to points items len -1. We have some index. We have b index is a index +1. We have a is points items at a index. And b at b index. These numbers are really fucking big. Right? So I think we just divide them by a lot. Res is I guess here we can do this. Max is 0. And here we're just going to be like max is the max of x and max. And y and max. And then I guess we do like a. I guess we can't just write it out yet. We actually need like an image buffer. So can we just do like a 512 by 512? And what do we need here? Like 1 for red, 2 for green, I guess. Something like this. So what are we doing here? We're going like a times 512 over max. Yeah. Like this. Throw some B's in here. Okay, and then we're like going to like image at like yeah, what is happening here? We're trying to like fill in the points, right? So it's like we have either this or this. We know that they're adjacent horizontally or vertically. So I guess like if ax is equal to bx, we do one thing. Else we do another thing, I guess. And if these are the same, we like iterate y. So it's like for ay to by plus 1, it's inclusive. We are doing image y times 512 plus ax is equal to 1, maybe 2 for green. So this should be like plus 1 like this, and then we make we do red in the corners. So ay by +1 or something? Maybe just like this. Yeah, it's like something like this. And then we invert probably. So it's like otherwise it's the x's that we're worried about. Yeah, like this. Okay. And then I think I feel like there's like an off by 1 in here somewhere. I feel like +1 here, I think. And +1 here. No. I've changed my mind again. I guess we will see. Medusa, thank you for the 2 gifties. Much appreciated. 512 hard-coded hard. Yeah, it's true. Then can we do something like write this out? 4. I guess we do like writer, write interface, write all, and that's like P6, 512, 512, and then I think you have to say the bit depth. I can't remember. Yeah, except it's 255 here. Okay. And then we go for image. We're looking at I guess it's like switch on the val. If it's 0, we print it's like write byte 0 3 times. I don't know. I think there's actually like a splat in here. Splat byte 3 times. If it's 1, we make it red. So this is 255.00. And then if it's 2, it's green. So flip these. And then we should be able to like flush this. Okay. Oops, is like this, like this. So true that we do want to splat this 0. I32 and U size, huh? Fucking div trunk here, I guess. Oh my god. Div trunk. Find this. Replace the comma. Find this. Okay. Boom, boom. Found U32. Which one of these guys? It's this Y, probably. Is this what he's looking for? I think so. Oh, no? Okay, who's mad? AX is an I32. AY is also an I32, no? Oh. Fine. Fine. we'll fucking int cast these as well, motherfucker. Ew. 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 Disgusting. Disgusting, man. Oh my god. Okay. Let's clean this up a little bit. Let's clean this up. Can we do like a little, like, put pics in image as this, A or X, I32, Y, I32, val, U2, and then this is, X, U, yeah, like if X is less than 0, or Y is less than 0, return, XU is int cast of X, and we have Y as well. Cool. Then we have image at YU times 512 plus XU is equal to val. Image width, fine. Fine, we'll fucking fix the 512s. Boom, 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 boom. Okay. I guess technically we should do it here too as well. Okay, and so now all of these guys are like put pixel image AYAX1 BYBX1 YAX2. Then this is image. Wait. It's XY, not. Oh, God. What if we just make it YX so that I don't have to fix the orders here? Easy fix. AYAX1, AYBX1, and this is AYX1. And then we just have to fix the for loops. So while AY is equal to, or like, Y is AY plus 1, while Y is less than BY. And then somebody told me there's like something where you can do like an increment in here. X is less than BX. X plus equals 1. X is equal to AX plus 1, like this. Okay. That print needs a little try on him. 87. I guess this can't happen. Wrong API here. Index out of bounds. Great. Why is that happening? Did I lose like some 512s in here? No. I guess if X is greater than or equal to image width, or Y is greater than or equal to image width. I just want to see like what's happening here. Std log error X Y. Let's just see. If it's like just a border condition, I don't really care. I think we might, or maybe I do, but let's just see. These are fucking numbers, not X and Y. Yeah, so they are just like just right on the border here. So I think the problem is that when we did max somewhere, when we did like the scaling, I think we just need to increment by 1 here. And then that won't happen anymore. Okay, cool. I mean, that looks like fucking wrong, right? Pretty clearly wrong? So what am I doing wrong here? So if we have the same x, then we fix x and we change y. And then otherwise we fix y and we change x. Okay, seems reasonable so far. Yeah, something's fucked here. I mean, it might be a circle. So there does seem to be some correctness here. Right? It looks like it's like horizontal. Can this be happening? This should never happen. Okay, interesting. So we're going for 0 to points items led -1. Okay. AX, AX, AY, AY, BX, BX, BY, BY. Okay. And then we are going from, you seem to not be tracing what goes backwards, like a starting point is lower than the ending point. Oh, yeah, you're right. You're right. You're right. You're right. You're right. Yeah. You're right. Good fucking eye. Good eye. So it's like a if AY is greater than BY, AY, BY, swap, swappy, swap, swap. These need to know what they are. Flip these in here. There we go. So it looks like I feel like why are we doing every horizontal line is red? Because we put 1 here instead of 2. Okay. There we go. So now this looks relatively correct, right? We see a bunch of corners that are red and, you know, some big lines that are green. And so it does look like there are no crisscrosses on this thing, which is nice. However, there are, it's not like a convex shape, right? But raycasting should still work, I think, on the corners. Oh, we're also missing the fact that we're supposed to fill all this in, right? Right? We're supposed to fill in all of this stuff inside. But we can kind of just know that that's fine. Yeah. Okay, so I think we only need to recast along the edges. And what do we think, like, the answer is? It's gonna be something that contains this edge, right? Maybe not, actually. Yeah, I guess it might not contain this edge because that would force us to use one of these corners, which is not necessarily true. Okay. Cool. Let's just recast the edges and see. So how do we do that? That's the next question. That's the next question. So like, say we pick this guy right here. I guess we iterate. Let me think for a second. Let's think. My gut says that you do something like you sort. So you have horizontal lines and vertical lines. You probably leverage that information in some way, right? You like split them. And then you probably sort the vertical lines by X position and the horizontal lines by Y position. And then you only have to check a few. Right? Because you only have to check the lines that could cross you. Yep. I think that makes sense. I think that makes sense. So what? It's like, I don't know what yet. Club function. Make line buffs. Line buffs. So you have our A of these be like this. I guess we can kind of do this as we go, actually. No. And now these are going to be disjoint, right? Yes. So technically, I guess each, like, this line and this line share like an X position here, but I think it's not worth representing that. I don't think. So let's just do this. And I guess you could get a little clever, where this could actually be like this, and you could have like a direction here. Right? So you could have like a fixed and then direction, which is going to be vertical or horizontal, right? I think that this saves some space, but in reality, due to like alignment of the structures, this won't actually, right? Because these guys, everything in here except for direction has to be 4-byte aligned, which means that this will end up taking up the space of a U32 or an I32, even though it doesn't have to, in which case this is just more complexity for no fucking reason. So we'll do A point, B point. We might as well. Oh, I guess actually we kind of know. That's not true actually, because the direction is kind of implicit in the vector that we, or like the array that we stored in. So we actually do save some space by doing that, right? Yeah. Yeah, it's something like this. Axis aligned vector. What a useless optimization, but it makes it fun, so fuck you. Okay. Also, technically, you could merge double horizontals, but I think I'm going to assume that that doesn't exist either. I think I'm going to make the assumption that lines are alternating. And if that's not true, then we'll fix it later. So here we have points as a bunch of points. And I guess we first like get the start direction. First dir is if points 0.x is equal to points 1x. Like horizontal. Next horizontal is this. For 0 to points len minus 1. I guess this is A index. Okay. Then we do something like with this. I don't know what yet, but we do something. B index is A index plus 1. And then we have like points at A index is A. Okay, and then I guess if next horizontal, we assert that AX is equal to BX. Next horizontal is equal to not next horizontal. And then I guess we have like A out is an array list of axis aligned vec. Like this. B out, like this, is returning line buffs. And why am I using A and B? This should be horizontal and vertical. And I guess if we have this, we can just do this. We can just support this case. If horizontal, oops, this is A, X, and BX here. Is horizontal, I guess we'll say. Horizontal append with A. This is actually untrue. It's horizontal if the y is the same. We got A is AX, B is BX, and fixed is AY. There we go. Else, we have vertical. Okay. Cool. And then we sort them at the end. And we're just sorting by fixed position, I guess. Dun, 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 dun. I guess technically you could use some sort of tree structure for this, but fuck that. It's like something like this, right? Return A fixed and B fixed. We don't care about the rest. Vert X, Y's backwards. It's true, we did copy paste with no regard for anything. Okay. So how do we do this? We have a sort here that takes in axis aligned vec. We have items, we have the context, and we have the sort function. And we could do this for both vertical and horizontal. Okay, and then return like this. And we are totally fine with leakies, so we just return items like this. We leak by design now. That's our thing. Okay. So can we do make line buffs with points items or something? And then can we fucking keep fixed buffer allocator? I guess alloc buff goes here, and surely a meg is big enough. Surely. Okay. And so here now we should be able to like rewrite this image stuff in a way that uses these line buffers, and then we can double check that it still looks like sane and correct, right? So for lines horizontal. Okay, let's do this. Let's leave the old thing here. And then we go for horizontal lines. We still have, we have A and B here are now kind of implicit. So it's like line A, and then the X goes away here. Then this is line fixed here. Then, so this is kind of just Y. And then we have BX like this. Right? Then we know that we are in the horizontal case, so we can kind of do this stuff. Yeah. And then we can do the same thing for vertical. So this is Y, Y, X now. Y, Y, A, Y, A, Y, X, X. Y, 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 Y. Nice. Looks about right. Okay, 96 is mad because this guy needs to be called fixed buffer allocator. And we have alloc is FBA allocator. Bang, bang, boom. Append here is mad because I made these guys const and that's not allowed because they are mutating. So we hit a couple of R's there. 45 is mad because this guy can return. Any chance you get a key press layout? I did make one at some point and I just never used it. Oh, this guy, this sort returns less than, not order. Interesting. Interesting. Like this. Lines horizontal is mad because this guy has to write try here. And let's see if that looks right. Okay, so good news, as long as we actually wrote something out. This sorted lines representation looks relatively correct to me. So now it should be as simple as I don't know what yet. It's probably like something very similar to what we were doing before, right? We check every pair of points. It's just our rejection criteria now improves, right? So we want to do like if reject box AB, probably something like this, right? Right? And then we probably need the lines to come in here as well. Right? Probably. Reject box lines, which is a line buffs. A is a point, B is a point, right? Okay, so what are we doing here? We are looking for the like lower bound. Okay, so I guess we want like, oh, hold on, I don't really know yet. So we have some box defined by 2 points. Easy. So I guess we want to look at if we shoot out in any direction here, do we cross a line, right? That's what we're looking for? Yeah, it's like something like that. So, I guess we kind of want like crosses line. And we can kind of represent it like this. Okay. And what are we doing here? It's like if AX is equal to BX, we do something. Otherwise, we assert that AY is equal to BY, right? Otherwise, it's like an invalid line to hit test. Probably. I guess we could do this instead. Okay. So then there's probably, we have like lines vertical here. So if the Y's are the same, then it's a horizontal line, which means that we're checking cross, like potential crosses is this, right? And then we have like A is A, Y. Yeah. So can we go like crosses line 1D or something? I don't really know a better way to specify this. So here, this is a bunch of axis aligned vec. We have A as an I32, B as an I32. And then we can kind of call here crosses line 1D with horizontal lines A, Y, B, Y, right? And then here, this is like this, just the opposite, right? So if the line is horizontal, we're looking for vertical crosses on X. Okay, now all we have to do is we have to like just implement this function. You're talking lines, but A and B represent box corners. Not here. In this, they are 2 points on a line. When we get to here, what we're gonna do is, yeah, you're right here that this reject box thing. Well, we haven't written reject box yet, but reject box is going to look like reject box still is A as a point as B as a point, but we're gonna go like 4-point pair A, B. You know what I mean? I guess it's like var iter is point pairs A, B. Or like line segments, maybe is a better word for this. Right? We can go like while IT next, we have pair. Then we can do like if crosses line pair A, pair B. You know what I mean? This is kind of what I was looking for. This type of shit. You know? Something like this. Line segments, A point, B point, like, I don't know, line iter, return. It's probably gonna be like this. And then I'm just not gonna implement this yet. But if we do this, we can kind of do, we can at least stub out the data. Point B is a point. Function next takes in a line, like self as a line iterator, returns a point pair, and we'll write unreachable here because I don't want to implement this yet. And I guess we need a point pair here. You know, something like this. Okay. But the part I'm actually interested in here is crosses line 1D. So I guess we're looking for min, I guess. Like lower is min AB, higher is max AB. Okay, we're gonna do something like this. I don't know what yet. I think we're gonna do like a lower bound to get the first line which this potentially could cross, right? So we're looking for lower bound. I think lower bound will give us the first element in items that is greater than or equal to context is determined by compare function. The index of the first element that is greater. The first element that is greater. Okay, so what about like the last element that is lower? Upper bound? Upper bound returns the first element that is greater. Whoa. Returns the first element that is greater, and this is lower bound is first element that is greater than or equal. Oh, nice. Yeah. So I want lower bound of lines. So if lines has like, 3, 4, 4, 4, 5, 5, 6, 7, 6, 7. And we have like A is 4, B is 5, right? In this scenario, we want to test all of these lines, right? So I think that it's like something like this where we want to get the lower bound for lower and the upper bound for upper, on lines. I guess we technically don't need to search both. We only need to search for one because we'll iterate naturally and run out on the other side. So we only have to find the lower bound for lower, I guess, right? And I guess this is going to give us something that's like axis align vec. I hope this gives us the index, right? Yeah, it does. So lines here. And then the context, I think, is void. Oh, no, the context is A. And then this returns... We need this guy to be a function that does this. Sorry, lower, not A. Okay. So context is I32. Okay, and then the value that's coming is axis align vec. Line. And we're returning std math order of line fixed and val, I think. I don't know which way this goes. Can we look for... So they do context item on these. Okay. So lower bound is this. I guess technically we can do this as like iterator here. And then we go like while IT is less than or equal to B. No. While lines IT is less than or equal to B. And like what and iterator is less than lines len. And this. Like this. We like hit test. We check if the Y of the line crosses our X or vice versa. Like, so we look at like lines A, like, I actually think I prefer writing this a different way, actually. I prefer writing this like this. If IT is greater than equal to lines len, break, then here we have this, and then what was our other exit condition? If line fixed is greater than or equal to is greater than B, break, I think. And then I think we say we do not cross here, and here we're trying to return true if is there like a between? So if we need our, like, fixed here. So if we are between lines A and lines B, return true. And then we just need a between. I think it's something like this. Compare against higher instead of B. So true. So true. It's crazy to me that, like, you can catch stuff like that. Like, you must be paying so much attention to notice that, or you're just like a programming god and I'm fucking stupid. Like, one of the two. Val A B and return val is greater than or equal to A and val is less than or equal to B. It's probably the latter, that he's a programming god and I'm a fucking idiot. That was an and on the second one. It's he's paying a lot of attention in brackets, or in brackets, he's a god and I'm an idiot. He can't be a god without me being an idiot, or vice versa. God, there's a lot that could be wrong in here. there's a lot we could have done wrong. This is a testy time. Crosses line 1D. So here we're trying to test that, I don't know, expect equal, what does this even look like? Oh, also we should throw in a fixed, x here and a y here. Okay. So I guess we want some line buffers. So here, I guess we have, like, A is 4, B is 10, fixed is 1. We are assuming that fixed is sorted, so let's do something like this. And then we just want to do, like, I don't know, 1 and 5, 3 and 9. This is gonna be hard to fucking test. I think that I need to draw something and then kind of work backwards from there, right? So I want to maybe draw, like, have something that looks like this. Probably something like that, right? So this is, like, fixed 1. Maybe we do something like this too, where we have 2 on the same line. So this is 1, 2, 3, 4, 5. So we have 2 at 3. And then let's do 2 at 5 as well. Let's do another one down here. And so this is kind of like, if we say that this is 0 and this is 10, this is like 4 to 7. And this is like 7 to 10. This is like 7 to 10 again. And then we also have a like 0 to 3 or something. Okay, then we have another 4 to 7. Then we have 7 to 10 and 0 to 3 again. And, like, honestly, we should probably fucking draw this, right? Because I'm gonna be, like, too fucking stupid to, like, diagnose this later. So it's like, maybe like this, and then 7 to 10, 7 to 10. I guess we're kind of missing, like, I guess it's like this, actually. Right? Something like this? This is 7, 10. This is 4 to 7. And this is 0 to 3. So this is 1, 2, 3, 4, 5. Okay, cool. Okay. So if our fixed, we're expecting a cross here. If we are going from 0 to 1 or 0 to 2, that should cross the first line if our fixed is at 5. Right? We need to specify that this is axis aligned vec like this. And let's see how fucked this is. Yeah, that's a good point. I guess this does need to be an array if you think about it. No A in axis aligned vec. Oh, because it's line and not lines. Okay, good news. And then if we do this on, 1 or on 7. Okay, bad news bears. Oh, oopsies, these should be false. So it actually is failing as expected. This one is not. Probably because it's inclusive. So we should make this 8 to 10. So that there is a gap there. So we expect it to be true if it's at 7, but false if it's at 8, because it's inclusive, right? Which means we've got a problem here. Right, so... Oh, because there's a line on 2. So let's make these odd, I guess. There we go. Okay, cool. Cool. So then let's test something that like goes in between here. So this is, can we also log these as 1, 3, 5, 7, 9. So in here we want to go like 2 to 6. Should be fine. False crosses line 1D on lines 2 to 6 on 5. Nice. And if we do true here without changing anything, he fails. And then we do 2 to 7 should cross. Nice. And ooh, wait, I think we want non-inclusive. Yeah, I think we want not inclusive because like when we're casting like this into like this line, this doesn't count. Yeah, so we want non-inclusive. Okay. Let me think. I guess this doesn't happen is also the thing to think about. But yeah, it's exclusive. So in here, maybe we bring this back down so that they touch. You know what I mean? And then the boundary conditions are simpler to test now. So I think we actually bring this back to 1, 2, 3, 4, 5. I think. And we are going from... Fuck. Dude, testing is so fucking hard. So this is at 0 to 2 in the middle. We are expecting a cross. Great. 1 to 2, we are not expecting a cross. And same with 0 to 1. We are not expecting a cross. All of these at position 5 in the center. Then we have the 0 to 2 case at 7 and 4. We are expecting these guys both to be false as well. Which is no longer true because our test is inclusive. So what are we doing? We're looking at all the lines, and this between now is greater than and less than instead of equals, which is still not correct. We are failing the 1, 2, 5 test. So what does that mean? We are like, I am trying to go from 1 to 2 between these two lines at position 5, and we are hitting 1. So what are we hitting? Hit line at this to this. This is so hard to interpret. Hit line at 4 to 7. 1. Yeah, so that makes sense. We hit this line, and then the question is why? So our fixed value is 5. And then we are between 4 to 7. Oh, this is wrong. This is upper bound plus 1. No. Hold on. It's here. We are iterating the vertical lines. We're trying to find the first vertical line we test against. And we want the first element that is greater. Yeah. So we use upper bound here. And so that means that we won't test the one on the left. And so wait, does this between change? No, I think that's still good. So we still, at 0, 1... Okay, that fixed the 1 to 2 case, but not the 0 to 1 case, because this needs a greater than or equal to here now, I think. Let's go, baby. Let's go. Boundaries are fucking hard. Boundaries are fucking hard, man. Okay. So this tests left edge and right edge, and then we wanted to test... Maybe this is fine. This might be sufficient. I guess we wanted to test in this gap too, right? So if we test in this gap, this is left, right, above, below, and cross of first line 4, 7. Then we want to test in between 1 to 4. So we are expecting, if we go from 0 to 4, we cross. Right? Because we'll hit this guy. Then we're also expecting, if we go from 1 to 5, we also cross the right side. But if we go from 1 to 4, we do not cross. That's kind of what we're expecting. Let's go, baby. Okay, then maybe, as long as we implement the line iterator for a box, I think we're good. So, I think it's like, if we are the first guy, we just have to pick an order, right? So we'll do this, 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 this. So this is A, this is B. The first one is A, Y. A is equal to AX, AY. B is equal to AX, bx ay, okay? Then 1, we're looking at a new point where we're looking for bx by here. If we're looking at 2, the new point is ax by. And then the third point is, I think as we just copy paste the a point here. Okay, and then we should be able to do like a little return here. And then defer index plus equals 1. Now, technically, it's better to kind of do this like this. Because then we can kind of do like ret is this guy, and we can say then only if index is in range, we do self index plus equals 1, return ret. Boom. Okay. There's like something here. All of these probably need like a self in here. And then probably this thing could actually just return the like fixed stuff directly, but like whatever. You know, something like this. What's he mad about here? Unreachable code? Wait, why? Oh. Okay. So then, do we have everything hooked up here? We have reject box here. Reject box iterates the line segments. We check if they cross the line. Cross line calls cross line 1D. Maybe. Everything might be in place here. Everything might be in place. Let's run this on the example and just kind of see what we get. Max area 50. So this is wrong. So can we see? Not sure what to do about this yet. Okay, so I guess we need to figure out why he's not rejecting that box. Right? That's the key here. So can we save lines somehow or something? Like we can test this explicit case if we are smart about it, right? Reject big example box. So we have our test input, which is this, right? Points, so we can kind of do this, I think, where like we paste this directly in here, and we just kind of like manually set these up. So this is like something like dot x is this, dot y is this, like this. This is a like point buffer. Then we have like our lines is line. Like, how do we make these? Make line buffs. Var FBA is stood heap fixed buffer allocator with alloc buff. We have var alloc buff is a meg of stack space like this. Okay, like this, bang, bang, boom. And then we can do reject box. And we are trying to reject the box at 211 to 11.1, right? That's what we're trying to do. So can we do x is 2, y is 5, x is 11, and y is 1. So we should be rejecting this box. We don't really know why yet, but expect equal true with this. And perfect. Okay, so now he's like, yo, what the fuck? And we can start trying to like log in here now. What the fuck is going on? So, line segment. First of all, let's see if these are right. Okay. So we have 2.5 to 11.5. 2.5. Okay. 2.5. Okay, so it's x2 to x11. So, and then, okay, so this is 2.5 here. And then this is 11.1 here. Okay, these are 2 points. So we see 2.5 to 11.5. Boom. We have 11.5 to 11.1. Boom. We have 11.1 to 2.1. Looks good to me. And then we have 2.1 to 2.5. Boom. Right? Beautiful. Okay, so that is fine. Then the question is also, can we look at the generated ppm here? Okay, so we are missing a line in here, which is a little bit concerning, right? So that could be related. And then also, have I changed my mind and this should be inclusive again? Unsure. I think that we need to be inclusive on one axis. I think we need to be inclusive on one of the axes. We're inclusive on the, it's like, so if I'm like in this case, this is interesting, right? It's like this box is valid. This box is not valid, right? And why is this box not valid? It's because he crossed this line here. But then, like, this box is valid, even though he crossed this line here, right? So it's like if this line goes down, it's bad, but if it goes up, it's okay. You know what I mean? Like, there's something here where the winding order matters, so we want to collide with one side of the line and not the other. Or something. Interesting. Interesting. It's like an inside-outside problem, right? It's like depending on the winding order. So we probably want to keep the winding order somehow. Yeah, not gonna lie, I just checked if the line was inside the box, but ignore the bounding box of the bounding box. I'm not sure what you're saying. Hold on. So I have a box. We start with a box. And so the obvious thing is, if there's a cross of the line, bad. There must be some pixels that are lost. But if this line comes like this, is it something about like count lines that intersect? Right, like it's something. So here, no, because that's like that count means that there is still stuff that's missing. But it is something about like border pixel count. Right, like that's okay, but that's not? Something like that? You know what I mean? My head hurts, man. My head fucking hurts. It always hurts. Um Yeah, I mean, okay, so first, I mean, we know that we have to fix the fact that we're missing a line. So let's fix that. So at the very least, this guy closes again, which is wonderful. Which is wonderful. And now let's think about this box we're not rejecting. So in their picture, in part 1, it's the box here. Okay. So we come up here, we cross this line, bad. But I guess if we want to check if it crosses inside. That's the trick here, right? Is that we know what is inside the box we're trying to draw. We don't need the winding order of the polygon. We only need the winding order of the box, I think. What the fuck just happened? Oh, I see. Right, so I'm trying to draw this box. And if this line collide is like inside the box, that's bad. Yeah. So we could maybe check this the other way. Instead of checking if the box crosses the line, right now we're kind of checking for like line intersection. It feels like you can do something like check if either point of this line segment is in the box. No, not quite. Because you could also cross the whole box like this. So that's not quite sufficient. But I think it's close. I think that if we just swap the order of something here, then it works. Because I think that if a line is fully in a box, some other line would have to cross the edge of it. I think. I'd be curious to try just swapping the non-inclusive or like the non-inclusive collision. It's like I'm trying to what is this guy doing? So we have the line and our 2 points. And we're saying if our fixed point is between here. So this is like it's so hard to reason about. It's so hard to reason about, man. So we have like, you know, these lines and we're testing our line like this. That's what we're doing right now. Is it the same? Is it symmetric? Is it symmetric? I don't know. I guess it's there's two axes of collision, right? There's like if my line that I'm testing hits, so there's kind of like this case, right? This case, this, like, and this case, right? So there's one where like our edge is hitting this edge, and there's one where their thing is hitting us. Now we are testing, the line we are testing is the line on the box, okay? And so what we have kind of said is, if all lines, if there are no lines that cross, but there are lines that touch, we're kind of think that this can't happen, right? Because every box that we pick is kind of made up from lines on the thing. So it's going to be like, if there's like a border condition, it's kind of going to be like this or something, right? So it's like, if the line, the like cross line only touches, we don't reject. But if we hit the line, do we reject? As long as we're not hitting the corner, yes. Right? So now, here, but back to this scenario, both of these crossings are happening on the edges of the line we're testing, right? So the box that we're drawing is like this, and these are the two bad boys. Boom, boom. So we can't just be like, okay, we collided here, we collided here. I'm so confused. But if we happened to draw this box instead, we happen to draw this box instead, we collide here and here. Interesting. Yeah, okay. I do think there's something about if line is inside box. I think that's the better way to go about this. Is it okay to give advice? I'd rather not. I'd rather you didn't, I think. Can we reject if all four corners aren't red or green? But I think that's not necessarily true. Oh, if all four corners aren't red or green. We don't actually know. We don't know right now if we haven't like checked. We haven't done the flood fill, if that makes sense, right? So we haven't filled this in yet. But you are right that we could do that if we had an easy check, which you kind of have by doing raycasting out and doing a count. You could do that, but I think it's better. I think I'd prefer to check if the line is inside the box. Think of U-shape. Oh yeah, true. You're right. That would still also work. Okay, I want to go back to thinking about we have the box, and is there a line inside? Because if there are any lines inside, that's fucking bad. So box contains lines, and the box is defined as as 2 points. Okay, so how do we do this? We look for all horizontal lines between top and bottom of box, and we look for vertical lines between left and right of box, right? And if any point on any line is inside, that feels kind of reasonable. So, this is sorry, this is a line buff. Okay. Yeah, let's do that. So X range is min AX, BX. Min X is something like this. Min Y. And then we have max here. And then we want first vertical is lower bound. Or is it upper bound? If the line is fully on our border, I don't think we give a fuck. We only care if it's inside. So we want upper bound. First potential inside. Min. Something like this. I think that's right. But just here, we're looking at min here. Okay, so we're like, first potential inside on vertical lines from min x, max x. Or min x, I guess. First horizontal is like this. Okay. So then we're going like for... I guess it's like... vertical line IT? Vertical line iterator. While vertical line iterator is less than max x, if line inside box, I guess if like line cross, oh wait, we have some sort of like vertical lines. We have like the lines vertical at vertical line iterator, and then if line crosses box, something like this. I feel like we're getting somewhere along here. Defer vertical line iterator plus equals 1. Okay, and then we just have the same thing with horizontal, right? Not sure yet. Okay. Horizontal here. Ooh, this line crosses box. This probably needs to be a little bit more explicit. Probably. Because this doesn't have the information about which way it's oriented. That's kind of like owned by which vector it's in. Okay. Line crosses box horizontal. So this gets me an axis aligned vector. And we're like, this is if we have either point is inside or both points are outside, or even both points are inside. So the only cases we don't care about are like this. Yeah, so it's like line A is less than AY, and line AB is less than AY. Less than or equal to? What's our boundary condition here? Yeah, we're fine with it touching. Return this, or they're both greater than. Line A is greater than or equal to... Hold on. lower is the min of AY and BY, and the upper is maximum. And then we use lower here. Yeah, so either they're both lower or they're both higher. Yeah, something like this. This feels like we're getting somewhere. Right? And then the vertical version is the same, just inverting the axes here. Yeah, okay. Sure. There's like a non-zero chance that this works. Can we do some tests here? Okay, so what is the fucking API of this? Lines AB. Oh, so can we try, we can just do the same test with reject box. Okay, so box contains line. Here is our points. This is our example. And we're expecting box contains line. True. Oh. So we're saying, fuck this reject box thing. Okay, so that's good. Box contains line is passing on the big box. And then if we change this from reject box to box contains line, what do we get? We get him fucking up. 107. So here he's pissed about if yeah, this is wrong. While vertical line is less than line's vertical len. Yeah, this is the same shit. While god damn it. While true, line is line's vertical line iterator, but if vertical line iterator is vertical line's len, we break, we defer a vertical line iterator plus equals 1, and then if line fixed is greater than something, max x break here, something like this. Something like this. And then this is all the same for horizontal. And then this is max y. And then this is all good, maybe? Like this. There we go, something like that. There's 2 plus equals 1 each. Is there? Yeah, there is, huh? There sure is. Yeah, I guess this defer should go on here on both. All right, cool. We got max area 30. Is that correct? No. So 9, 5, and 2, 3 should get angry. Let's see if he does. Oh, oops. This should be false, actually. Okay, so why is this not working? Why is this not working? So 9, 5, 2, 3. We need to draw it. Okay, can we do this? Whoop, whoop. So we have x7, y1. That's probably here. 7, 1. This is 11. This is 9. This is 2. And then this is probably 3, 5, 7, right? Okay, so 9, 5 is here. 2, 3 is here. So this box is fair game, but he doesn't like it. So which line could possibly be intersecting here? It would have to be this one, right? But we'll see. Any crosses. Okay. So we're seeing A3, B1, fix 7. So that's this line. He's saying that this line crosses. Okay. Why? Oh, oops, this is wrong, right? Is this inverted? Line crosses box horizontal? Yeah, this is backwards. There we go. Okay, max area 40? Not good. Okay, so what's going on there? What box gives us 40 here? Probably 7. This is 6 across, and this is 4? No. Maybe this one? This is 4 down, 10 across, right? 3 to 7. 3 to 7, 2 to 11. Yeah. 3 to 7, 2 to 11. We're expecting a true here. Okay. Is there another 40? Where is this 40 coming from? Counting this guy. Area A and B or something. Maybe render the box on top. Yeah, I think that's like not like super trivial to do, but it's probably worth it. Probably. But whatever. We'll start here. If it gets too out of hand, then we'll do that. So 40 is coming from 9, 7 to 2, 3. Okay. 9, 7 to 2, 3. So that is this box here. So we are expecting this line to cross, right? And that's failing. Okay. So then the question is what the fuck? Why the fuck not? So this is a horizontal line. If fixed is not greater than or equal to max y. Okay, I guess we'll do here. So we'll say a std debug print testing this line. Right? So we should be seeing, I guess, right before he fails, we should see him testing 2 to 9 at fixed 5. So he is testing this line. That is happening. Right? That's great. So then that means it's in here, where if... Oh, we only fixed one axis. That's why. Oopsies. We had the condition inverted. All right. Max area 24. That's really promising. Now, there's lots of places where we could have fucked this up. Lots of them. But at least we have a promising potential thing. I'm kind of down to just fucking run it. And if we get the right answer, we get the right answer. If we don't, then we have to try a little harder. Let's go! Hell yeah. Okay. So that was a lot harder than I expected. I think it's the like figuring out what conditions to test on those like edge checks is kind of hard, right? We could have pretty easily just painted the whole thing. Although I guess doing the flood fill of the green tiles would have been hard. But once you have the flood fill, then you could do like the stupid thing where you just iterate every tile. But we did something a little bit more intelligent, which was a little bit hard. Can we kind of try to reduce this down to like the minimal thing required to solve this? So I think we're not using this line iterator anymore. Line segments. I think we're not using this because we're not using reject box anymore. Yeah, okay. So we can delete all of that. I think we're not using crosses line anymore either. I think that's gone. Yeah, this is dead, which means crosses line 1D is gone and all of the tests that go with it. But we are still using box contains line. Yeah. What about this? Yeah, okay. Then we're using this, we're using this, we're using this. Okay, so then there's like some like render, like some drawing stuff that we're doing that we're not using anymore. But this is used, acts as a line vector, line buffs, which sorts the points into vertical and horizontal lines and sorts them accordingly. We've got we do like a binary search to figure out the first line in our sorted list of horizontal or vertical lines that could contain the point. This is definitely duplicated in some way that we don't want, but we check now if for each horizontal line or each vertical line, boop, 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 we check if those end up inside the box at all. This function, there's definitely something in here where the two axes can be like combined. I just don't have it yet, so there's a lot of duplication in here that that we'd fix if we were like actually committing this code. Then in main, what do? We like parse the data, we shove it into the points buffer, and then we convert that into vertical and horizontal lines. This is all rendering code, so this is actually not part of it. This is all rendering code as well. This is the actual loop here. So we go for each pair of points, check if the box contains a line, send it. Sick. Sick, sick, sick. That is right on the 2-hour mark, which is funny. We did part 1 in like 10 minutes after reading, and then part 2 is like almost 2 hours. I suspect that if I were to continue on with day 10 right now, I would burn out quick. I think that I would not have fun doing it, and the whole point of this is to have fun. So I think that I'm going to call it here and say I'm happy with the progress on day 9, and we'll do day 10 tomorrow. How did your custom renderer go, like from a few months ago? I don't know what you're talking about. Are you talking about like the fake GPU that we made? It ended up being able to render the spinning monkey, which is pretty sick. Yeah. Okay, we'll do day 10 tomorrow. Yeah, day 10 was rough. Ammo? Okay, nice. Then that'll be a good one for tomorrow. We'll come back tomorrow. Happy December 11th. Thanks for watching, guys. If you like what you saw, we're working on a couple other things right now. We're working on the Wayland window manager would be the main one. I've been doing a lot of like off-screen cleanup for the debug stuff required for that. We'll be back on that when we finish Advent of Code. There's some stuff, sometimes we do some streams that don't end up in the YouTube. If you want access to those, Patreon, YouTube members, Twitch VODs, if you pay in the appropriate place, you get access to those, and you also help the stream continue for a longer term, because when I run out of money, I will have to get a job. And so these streams will end. But obviously no pressure. That's all the plugging we gotta do. YouTube, peace out, and Twitch, let's find someone to raid.